In this video, we will talk about 3D constraints. Okay, so we have already studied constraints in Sketch earlier. So let me show you again. So these are what Sketch constraints look like, and we access these constraints from this bar. So now look at constraints in part. So when you have more than one solid in one part, we can use these constraints, but it is not recommended because if you are having a fresh part, it should go in a fresh file. Okay, we should not have multiple parts in same file. Every part should have its own file. It should be like that, and it is recommended. Still, if it is asked like if you know 3D constraints, then one is this. Okay, so we choose this constraint, and first of all we need to fix one because these right now both of them they are on absolute, and depending on a bigger assembly we need to identify one of them and make them fix. So say I want to fix this part, so I choose this constraint option and I click on this one. So it has fixed this part because this is the first default constraint what Catia put. Okay, now the second constraint is that I want to show you. I want to align this spacer with this face. So what I will do is, I hope I can move it. No, I'm not able to move it, but say I align it. I constrain this face to this face. Okay, you can see it is showing the dimension right now. The gap between those two faces, it is 160 millimeters, and we can actually make it 0. So right now it is in contact, and in case I want to move it on the other side, I just double click it. I get these options. Say I want to make a gap of 10 millimeters, but on the other side. Right now, if I put 10 millimeters and I click OK, it goes inside it. And giving a negative value is not recommended. So we go here, we click on more, and we click here. We choose the reverse direction, and now we click OK. So now there is a gap between these two components. So this is 3D constraint, but it is just an example. There are more commands and you can look at it. Uh, but it is not recommended. So we should always use constraints in assembly. Okay. So let's discuss about assembly constraints. So I'm just going to go back and reverse the changes that we just did. Just close this part. And we have here, I delete this and I delete this also, and we close it. We don't want to make any changes, and now we have our assembly. Let's say we open our assembly workbench, and one by one we import all these parts to it, and they come like this in space. Okay, now we need to constrain them with respect to each other. So we have a command palette here. So this is our command palette. So before we go into constraints, let's just discuss about degrees of freedom. So with degrees of freedom, we will understand like what is the reason we are using constraints, and um, how we should use them. Okay, so when we are working in a 2D two-dimensional workbench, let's start it with an example. I need an access system actually to make it look better. Say I'll just open it in another window. Okay, Okay, so this is the axis system. This is x-axis, this is y-axis, this is z-axis. Suppose we have a small part here, say a box. So it can move in x direction positive. It can also move x direction negative. It can move in z direction positive, and it can also move in z direction negative. Again, it can move in y direction also, and it can move in negative y direction also. So these are like uh, three translation degree of freedoms, and apart from that we also have three more degree of freedoms, which is rotation along x, rotation along y, and rotation along z. So this rotation can be positive or negative. So together this makes 6 degrees of freedom, and using 3D constraints in assembly, we constrain these 6 degree of freedoms. So let's go back to our Catia, and we go back to our assembly. Okay. So first thing is we need a base part to which we are going to attach all the other parts, and to make sure our base part doesn't move, we use this fix component. So what fix will do is it will fix all the 6 components of degree of freedom. It will uh, so there will be no freedom for this part to move anywhere. So it has fixed it, and we can consider this our absolute zero as of now. Next is uh, we have this one, say coincide. So using this, okay, this it is it is active right now, and we can actually coincide the axis. So first of all we need to put this on top of it. So say we coincide the center axis of this part to this part. Okay, so there is a link between them, and you can see that the coincide it has appeared here. So we need to right click and we need to give an update. So the moment we give update, it will move, and it will follow the coincide constraint. We have done a coincide, but the problem is it still has some degree of freedoms. And how we can identify the further degree of freedoms for this blue part is we have this command palette here, this one. It is called manipulation. So in this we have this first option, which is manipulate, and it will open further options. So in this we can try moving this part using this possible degrees of freedom. So let's say we try to move it in X. We need to check this option with respect to constraints, so it will follow the constraints. So without checking this option, it is just blindly doing the operations. So say we check this option on. Now we can't move this part in X direction. Say we try to move it in Y direction. Yes, there is a degree of freedom in Y direction that we need to fix. Then Z, so we cannot move it in Z direction also. So two translation degree of freedoms are fixed, and only one is not fixed. Then there are these options in which we can try moving this component in different planes. Say we try moving it into XY plane. Yes, we can move it in XY plane, but it is moving along Y only. It is not moving along X. And similarly for YZ also, it is moving along Y and not along Z. And if we go for XZ plane, it is not going to move. Then we have rotation. We can check the rotation along X. So let's say, so we are not able to rotate it along the X. This degree of freedom is also fixed. Along Y, yes, we are able to rotate it along Y, and we can see that this component is rotating. Okay, so this means that this degree of freedom is still open. Then let's check if we can rotate it along Z. So no, we cannot do it. So this is how we can check like if there are still some open degrees of freedom. Okay, now we can close this one. So we understood that only rotation degree of sorry, only the axis is coincide. Apart from that, it can still move up and down, and it can still rotate around its own axis. So fix these two more components. Let's use manipulate again, and we move this part in y direction, and we click OK. And now we provide further more constraints. Say we provide more coincide constraints between this axis and between this axis. So now it cannot rotate along the center axis, but still it can move up and down. So we can again make use of coincide command, and we can coincide these two faces, or we can use this command, which is contact constraint, and we can select this face and that face, and it will create a contact between those two. And we also have this offset constraint. So what offset constraint will do is uh, we can provide some value. If we give 0, then it becomes a contact constraint. So that is how these things work. So now we have captured all the degrees of freedom, and we just need to give an update. So it has moved here, and now we can see that using manipulation we are not able to, sorry, again I forget to check this on. We are not able to move it up, or we are not able to rotate it anywhere. Okay, so similarly let's constrain other components also. So we have put this here. Now to fix this spacer with the housing, we use these screws. So we can simply use a coincide command, and we can do like this. We can double click it so that we no need to go and activate it again and again. So, and this one here, say it goes here, and now we give an update. So all these three screws are moved to the position, but they still need to be, they are aligned with the axis, but still this degree of freedom is not fixed. So let's use this command this time, offset constraint, and we select this face and we select this face, and we can provide a value. We can simply give 0 and click OK, and we update it. It will come and fit here. I can still change this value. Say if I make it 10, then there will be space between them, just like we were doing in the beginning, but we were doing that inside a part. So this is how offset constraint works. We want it 0 as of now, and we have already understood contact constraint earlier. Okay, so let's quickly fit these screws. Use this one and this face. Okay, and again this to this face, and we give an update. So all these three screws are in position now. Next, we need to put in this shaft, but there is a small assembly to this shaft. We need to put this wall plate, and we need to screw it. We need to screw this wall plate to this shaft. So we cannot fix this one. This still need to go inside it. But say that we don't want this shaft to move, and we want to assemble it here only. We can use the fix command. We fix it here, and we will later delete this fix constraint. Okay, so now we will just put this plate on here. So we give a constant contact constraint. this face to that face, and we update it. And now we need to align these screws. So we give this command coincide constraint this screw to here and this screw to here, and we give a update. I wonder why update is not coming. Okay, they are already coincided. That is the reason the update is not coming. Now we give contact constraint. We double click it. We make contact of this face to this face, and we do the same. This face to this face, and now when we update it, I guess the last constraint didn't work properly. Let's do it again. Okay, there is already some constraint. We need to check. Let's try it again. This face in contact with this face, and we give a bit. Okay, now it is in position, and because we have constrained these components with this shaft, and we need to move this shaft and align it with the main housing, we can delete this fixed constraint. Okay, and now we can align this shaft to this pink housing. So again we use coincide constraint. We coincide the center axis of this shaft with the center axis of this housing in this direction, and we just give an update. So it is in position, but still there is a problem that it can move up and down. So to restrict those degrees of freedom, what we can do is we can give a offset constraint of this face to this face, and we click OK. So now this cannot move in up direction. Now this cannot move in up direction. I guess it can only rotate now. Oh, this thing is moving. So we need to constrain it properly. I guess I have not given a constraint between this hole and this screw, or this hole and the hole in this shaft. So I just let's just okay. I need to move this from the way because I need to expose the hole. So I choose this, and I not able to move it. It should be able to. Okay, leave it. What we will do is we will move it here. We click OK, and we will give this coincide constraint between this and this, and we update it. I think this thing can still rotate. Let's check with respect to constraints. Say x-axis. Yeah, this thing is rotating. You can see that it has completely rotated. We need to fix this screw here, so we again give this one and we fix it here and we update it. Okay, now it cannot move. This shaft it's supposed to rotate, so we really no need to constrain the rotation. This rotation we don't need to constrain because this shaft need to rotate along this axis. Next, what we will do is we will put this handle into the play on the shaft. We will put this handle on the shaft, and then we'll screw tight this handle using this nut. So let's do it. We use a contact constraint. We need this face to be in contact with this face, and we will use coincide constraint because we want this center of this hole to be coincide with this, and we give a update. This comes in position. Now here the problem is this shaft, it can rotate. uh, I'll tell you what the problem is. I'm not able to explain it. Say, suppose I choose manipulation and I give rotation. So when I rotate it, this handle is rotating, but this face is not rotating. And it should work as a single assembly such that when we rotate this handle, this plate should also rotate. So to do that, we will use next constraint, which is angle constraint, or we can also use this one, which is called as fixed together. Okay, so angle constraint, what it will do is it will give a angular constraint like this, and it is 72 degree right now. If we want to make it, we can make it 45 degrees also. Okay, we give a update. Now it is on 45 degrees. Or we can use this one, which is called fixed together, and I can choose components, this one, say this one, and say these screws. So these are the list of components, and the moment I click OK, all these components are fixed together now. So now this will not work. Now when I rotate this whole assembly of this handle with this shaft and this wall plate, it will move together. So that is how the constraint works. So finally, we need to put this screw on the top. Let's do that. We use contact constraint, and the bottom face of this screw we select with this one, and we also need to align the center axis, this, with this axis, and we give update. So now our assembly is complete. So this is how constraints work in assembly and in a part file.